you can begin.
All right, well, good afternoon, everyone. My name is Kate Davenport. I'm one of the co-presidents of Eureka Recycling. We are, it's not moving. Eureka Recycling is based in the Twin Cities in Minnesota. We are a 501c3 nonprofit social enterprise. We've been around since 2001. Oh, it's on some. And our mission is to demonstrate that waste is preventable, not inevitable. And what makes us unique in the industry of recycling is that at our heart and our core, we're an advocacy organization and education organization around zero waste. And we utilize our recycling operations as a way to demonstrate what role recycling has in getting us to zero waste. It's not the only thing that's going to help us get there, but it does have a key function. So we really utilize our operations as a laboratory to understand from the collection side and the sorting side, from the education side, from the market side, what role, again, does recycling play in waste reduction. And we really approach zero waste from three perspectives, and we see zero waste strategies as solutions to climate change, local economic development, and environmental justice and social justice issues. And I'll speak to two of those quickly. Climate change, and that the things that we consume in our lives, the packaging that our products come in, et cetera, is a reflection of resources used to get those products to us. And so it's not just about the environmental impacts of that material going into a landfill or an incinerator, but it's also about all of the resources and energy used to make that product. And so we really look at recycling, again, not just about what's coming out at the end of the tailpipe, but what went into making that product. And so if we're to recycle it, or even better, reduce that packaging or that material, what climate change and environmental impacts does that have? We also look at this from a local economic development perspective. So how can we take our operations and the supply chains that we sell into and focus on local and regional markets from a job creation perspective? Recycling is a global industry. And then also from an environmental justice perspective, when you look around the world, the communities where landfills and incinerators are sited are typically almost always in low income and particularly communities of color, and therefore they're carrying the burdens of the negative health impacts from those sightings. And you see that also in terms of industry. And so we look at that in how we do things, and we also look at in terms of how we recycle, how we pay and treat the people that work here is all a part of the equation. So we look at that from a holistic perspective. So a little bit more about Eureka. I mentioned we're a nonprofit social enterprise. We were launched in 2001 and really started operations in 2002. We hold the two largest recycling contracts in the state with the city of Minneapolis and St. Paul, as well as several other suburbs in the Twin Cities metro area. Last year we processed around 90,000 tons. We're actually this year probably headed more to the 115,000 tons per year. So we do anywhere from 350 to about 450 tons per day run through the facility. And I'll note here, you'll hear me say this term and see that term MRF, M-R-F. That stands for Material Recovery Facility. So that's where the recycling that's picked up comes, and then we sort that into materials and then sell that into different markets that turn it into new product. So we're not turning anything into new product at our site. We're simply taking all that material that comes in, that gets mixed together by the resident, and sorting it back out into glass, paper, different kinds of plastics, etc. We do also have a collections fleet. We have about 30 trucks that are going around picking up recycling every day, mostly from residential properties. We do about $14 million a year in revenue. Obviously, a lot of that goes to covering the operations, but we also take the profits from that to invest back in research and advocacy work. So we do policy work on the national, state, and local level. We do research as well as education in the community. So I think it's important when we talk about recycling about why do we recycle. The goal is not to recycle in and of itself. The goal of recycling is to help us reduce our use of natural resources and lessen the impacts of consumption. And so when we look at why do we recycle, we look at that from changing our consumption patterns towards zero waste. We look at it from an environmental and human health perspective, and we look at it from a technical feasibility and economics perspective. And you guys are probably a good audience to think about this, and you probably understand this better than most. But in reality, anything, if you can figure out how to get it back into its core original material, could be recycled. But should it be recycled? Is recycling it actually helping us lessen our environmental impact on the planet? Is recycling it having less or more impact from a human health perspective? And is it technically feasible and economical to recycle it? So there are lots of products out there that technically you could recycle, but there are technical and economic challenges in terms of actually getting that material recycled. Or there's material that you technically could recycle, but recycling it has a really negative impact from an environmental perspective, and recycling it doesn't actually really help to reduce the overall presence of that material in our society. Polyvinyl chloride, or number 3, is a really good example of that. That's a kind of plastic that technically you can recycle, but is it something that we really want to recycle? Because as soon as you recycle something, it takes away the pressure from looking at actually reducing or eliminating that type of material from our economy. So our kind of, I'll say actually before I get into the details here, some of you may have been following this, but the recycling industry in the United States has been in somewhat of an upheaval in the last 2 years. In the United States, about 30% of the recycling material that was collected in the United States was sold overseas, primarily to China. That happened the most on the coasts, on the west and east coast, in large part because of shipping costs. It was actually cheaper to send recycled scrap material back in an empty shipping container that had brought our iPhone over than it was to ship it into the middle of the United States, where more of the paper mills and recycling plastic facilities are located. China in 2017 started placing really strict requirements on the quality of recycled material that was going into Chinese markets. And then this, in the summer of last year, stopped accepting most material, and it resulted in a huge glut of material in the U.S. markets and massive downward pressure on pricing for recycled materials sold by facilities like ours. We saw probably about a 30 to 40% drop in the average value of material that we sold. And I'll get a little bit more into the dynamics of that in a minute, but at Eureka, because of that emphasis on local economic development, we've always focused on local and regional markets from a resiliency perspective and, again, from a local economic development perspective. So about 80% of the material that we collect and sort is sold to markets in Minnesota, about 90% to markets in the Midwest, and 100% of our material stays in North America. We have exported some material to China and South Korea in the past, but we've always done our due diligence in terms of what the materials being turned into and what are the working conditions of the people that are in China or South Korea that are recycling the material. Sorry. So we have definitely been impacted by the decrease in pricing, even though we've sold material mostly regionally and locally. We're dealing in global commodities, so we, again, have definitely been impacted by that price to the point where the revenue that comes in for the sale of material does not cover the cost of processing anymore. And so our customers, like cities and other haulers, are having to make up that difference. Whereas 2 to 3 years ago, the cities and haulers that we work with were actually getting a revenue share or a rebate on the material that they brought to us. I think it's important to note at this point, and particularly because there's been a lot of press around recycling isn't working anymore, et cetera. Our perspective is that recycling is a really key part of a zero waste approach to our consumption, and that when you look at the price of recycling, although the value of the material may not be covering processing costs, it's still less expensive financially than disposing of that material in a landfill or an incinerator. And even if it isn't in some cases, it's still better for the environment than the externalized impacts of incineration or landfilling. So we've had a reputation for quality material over many years, and that has led to valuable long-term supply contracts and investments by our market. So part of what China was pushing back with in the last 2 years is that they were buying, for example, scrap plastics, scrap paper from U.S. markets that were really contaminated, meaning they'd buy a shipload of paper, for example, and it would be 20–30% non-paper material. Now, it may be plastic or other recyclables, but there was a cost to the paper mills to clean that up. Or it may, for example, they were selling number 3 through 7 plastics to China, and there was a lot of non-recyclable plastic or just other trash that was coming along with that. But as I noted, because of our kind of philosophy and approach, we've always had a reputation for good quality material. One example of this is that we have a long-term supply agreement with the WestRock Mill in St. Paul, Minnesota. So most of the newspaper, mixed paper, junk mail, cardboard that we collect goes to the WestRock Mill that has 300 jobs there. They make cereal boxes. And so, again, that's an example of us really trying to look at where there are local economic development opportunities. We also do the same thing with some of our plastics markets. And part of our ability to do this is also because of our location in the Midwest. Sorry, not sure. I spoke before about our commitment to understanding where material goes and what it turns into. For us, recycling is a material is not recycled when it's picked up from the curb or picked up from the alley in the cart that you have out as a resident. It's not even recycled once it leaves our facility. It's recycled when it turns into a new product. And so we look at, again, where is the material going and what is it getting turned into, and is it getting recycled into its environmental highest and best use? It's one thing to take a plastic bottle and turn it back into a plastic bottle. That has more environmental benefit than taking a plastic bottle and turning it into a McDonald's toy that's then eventually going to get thrown away. And so we look at that when we look at selling material. Is it getting turned back into a bottle or a type of packaging so that it has the ability to be recycled a number more times? Remember, we're recycling at the end of the day not just for the sake of recycling. We're recycling to take a bottle to turn it back into a plastic bottle so that we need less petroleum to make new plastic bottles, or we need less virgin fiber to make cardboard boxes. That's the real goal at the end of the day, and so having an understanding and commitment of what it's getting turned into is important. The next piece I'll just highlight is, and you can see here that our staff here are paid living wages with benefits and paid time off. And we do that from a values perspective and from an environmental and social justice perspective. The recycling and waste industry is the 5th most dangerous industry in the country from a worker safety perspective. And it has been very typical over the last 20 to 30 years that the staff that are sorters in a material recovery facility are often temp workers. They do not receive health insurance benefits nor time off. And so there's been high turnover and a lot of safety issues. And so we felt like both from a values perspective but also from an operational perspective, it makes sense to invest more in our people and our staff up front. We have really good retention and very little turnover, which is pretty rare in the industry. And we're doing this obviously because we feel like it's the right thing to do, but it's also important to demonstrate to the rest of the industry the business benefit of doing what we do. And I'll make a note here, too, that we do not subsidize our operations here at Eureka. So we're not getting grants in order to pay our staff more or to pay for equipment. And that's very intentional. Because we're trying to push the industry, both for-profit and nonprofit, towards better practices, and our demonstration isn't as valid if we're subsidizing that with grant dollars, for example, that the private industry wouldn't be able to access. So a couple more slides here, and then I'll stop for some questions. Again, we're really approaching changing systems towards zero waste, not just to recycle for the sake of recycling. And so when we look at whether we're going to accept a particular material into the program, for example, we get retailers, manufacturers, consumer goods companies approaching us all the time saying, we want to add this type of packaging. We want to say that it's recyclable. We want you to accept this. One of the first questions we ask are there viable end markets? What is the ability for that material to be recycled again? Does it reduce the demand for extraction and mining of resources? And is there transparency and ability to verify that? That's a really important question for us. We also look at, is it made with renewable resources or petrochemicals, and is there an ability for the material to eventually be part of a closed loop system? Even in the case where you're recycling plastic or paper, there's only a finite number of times where that material can be recycled back into product through mechanical systems. So again, we're really approaching recycling from a zero waste perspective and getting at the original meaning of recycling. I'm actually going to kind of skip. These are some other things that we look at, which is what alternatives are available for the item and how do they compare. So a great example of this right now is there's a lot of discussion about the recyclability of Starbucks cups. Starbucks cups, when you go and get your coffee, are paper with a plastic coating on them, and they're currently not most paper mills that recycle paper can't take that material. So there's been a significant amount of investment. There was just recently a prize run by the Closed Loop Fund about coming up with a recyclable and compostable cup. And although we think those efforts are good, we feel like the investment actually really should be made into waste reduction and reuse systems. Even if you can recycle the cup, is that actually really helping us get towards zero and lessen our environmental impact? Or are there, again, waste reduction or reuse systems that can be invested in? Recycling isn't always necessarily the holy grail. The other thing that we look at in terms of adding material to a recycling program is the impacts on educating residents. How easy is it to educate a resident around how to properly put a new material into the stream? And one thing that we often find is that you may have one brand that has designed a piece of packaging in recyclable material that could be recycled and go to market, and another that hasn't. And so we tend to be very hesitant to add one particular brand to a recycling program versus another, because it's nearly impossible to educate residents to recycle by brand versus material type. And I spoke a little bit about this before, but again, we're always looking at recycling through the lens of environmental and human impacts, health impacts of extraction, manufacturing, and the end of life. So I'll speak to this and kind of stop here and go for questions. Again, when we're looking at whether we can or cannot recycle a piece of material through our program, through a residential recycling program, we're looking at markets, but we're also looking at what's the cost to sort that material. So I think often people think in some ways that when they put their recycling in their cart at the curb, it goes into some magic black box and is turned into a new product. But it actually comes to our facility, and we have to sort that back into different types of paper, back into glass, back into aluminum cans versus steel cans, and then into about 4 different grades of plastic. And so what is the cost of sorting that material? What's the equipment investment? What's the value in the marketplace? There's a wide range of values for the material that we sort, and what's the return on investment? And we also look at capture rates. So are we going to be able to effectively capture that material? One example that I would probably make sense to a lot of you is really small pieces of plastic. Yes, they technically might be made from a type of plastic like polypropylene that has a market, but can we actually, since it's so small, effectively sort that material and get it into the right material grade to sell? And if we can, what's the cost of that and the return on investment? So those are a lot of things that we look at. We also look at, as I mentioned again, markets, but wanting to make sure that they're stable and consistent markets. If there's one market somewhere that somebody's had for 6 months, from our perspective, we need to see more stability and more variety of markets before we'll add something to the recycling stream. The last thing I'll note before taking questions is that when I'm speaking about recycling, I'm talking about what is often referred to as curbside or residential recycling, so the material that a resident is putting out, or say in an office building or school or something like that. There are other materials out there that we do not accept that are recyclable, for example, electronics. We don't want electronics to come through a material recovery facility to go in the cart that you put out every week or every 2 weeks, but there are drop-off places that you can take those electronics. And I think that can be really confusing to the public, that something can be noted as being recyclable, but it's not actually recyclable in their curbside program. And there are a lot of reasons for that. You know, electronics, if you mix those electronics in with bottles and cans and paper and put it in a big truck that compacts it and brings it to a facility, by the time it gets here, it's not viable to recycle it anymore. It's been pretty damaged in the process. So maybe I'll just stop there and see if there are any questions. The next piece is I'm going to get a little bit more into the technical aspect of how a MRF works. Okay, so I'll describe a little bit here now how a MRF works, a material recovery facility. So a great way to explain it is that a MRF unscrambles the egg. The resident or the restaurant or whatever gets the benefit of mixing all that stuff together, the convenience of that, and we got to figure out how to unscramble it. And so we sort with a mixture of machines and people, and we sort material by shape, weight, and size. And so this is a diagram of the facility that will soon be out of date, actually, because we're adding some more equipment. But if you see here, number 1 is the material comes in, it's dumped out of a truck, and then this loader here puts it into a hopper, and it's all mixed together, and it goes up this where you see number 2, it goes up this conveyor. That's a drum there that we call a metering device, and that's how we control the speed with which the material is running through the system, by lowering and hiring that. And it goes initially into what we call the pre-sort house, where you see an initial group of people there. Can you guys see my cursor? Laura?
Yes. Yep.
You see the cursor?
Yep.
Okay. So it goes into this area here, which is called the pre-sort. And that's where we're trying to pull out any material that we don't want to run through the system. The majority of what we're pulling out in here is plastic bags. So either people that think plastic bags are acceptable in their curbside program and put them in, or they've bagged their recycling. And so we're having to break those bags open. There's actually, I'd say this is an art more than a science. It takes a lot of skill and training for our sort staff to know when to open up a bag, because we also get bags of trash. We also get a whole lot of electronics. We get frying pans and toasters and vacuum cleaners. In the summer, we get lots of garden hoses. In the holiday time, we get lots of Christmas lights, coat hangers, all of those kinds of things. We try to get out for those coat hangers, extension cords, Christmas lights, and the plastic bags we call tanglers, because they'll actually wrap around the shafts of our equipment. So we spend about 2 to 3 hours a day having to climb into different parts, different equipment here, and have to cut plastic bags and extension cords off of the shafts of the equipment. The scrap metal that we get, so again, we get pipes and all kinds of stuff. That stuff can be really damaging to our equipment. We've had motors break off because a pipe flew and hit the motor. So we're trying to do everything we can in here to get out everything we don't want to run through the system. And obviously, you're educating residents to not put that material in. That education is only so effective. And most of the material received are being picked up in carts. And so unless that cart, when the driver picks it up, has the driver can see the vacuum cleaner, then it's very hard to see that material at the point of collection until it actually runs through the system. Or in the case of a dumpster, a vacuum cleaner can be buried at the bottom of the dumpster, or the dumpster is picked up automatically without the driver getting out of the truck, so they don't necessarily see the contamination in there. So this is a really key place, again, where we're trying to get all the contamination. And this is part of what we call our residual rate. We do try to pull out and save the electronics and send them to an electronics recycler. We do have to pay to get rid of those electronics because of the condition that they're in. So the next thing that happens here, you can't really see it, but the material goes off the conveyor and goes through what we call a glass breakage system, where we purposely break the glass into pieces of about 2 inches or minus, and then it falls through a screen out of the material. We're trying to pull the glass out as soon as possible so that it doesn't cross-contaminate other material. And then where you see number 3 is what we call our old corrugated container screen or cardboard. And essentially what that is shafts with very large metal discs with about 1.5 foot of space in between each disc. And so large pieces of cardboard float over the top, and all of the other material, the bottles and cans and smaller pieces of paper, fall through the cracks. And that's how we sort out the big pieces of cardboard. And then the next step in the system here, where you see 6 and 7 and 8, is all a series of screens and shakers that are separating paper from containers. Again, using a system of screens where you have rubber discs that are grabbing the 2-dimensional paper and it's floating over the top, and the bottles and cans that are 3-dimensional are rolling backwards. So again, we're using shape and size and weight to separate paper from containers. This is the part of the system right here at the beginning that really makes it single stream or single sort, because that's where we're, again, separating those containers from the paper or the 2-dimensional. One of the things that's become really challenging in the last few years is something the industry has tended to call the Amazon effect, which is if you came to a material recovery facility 7, 8 years ago, most of the cardboard that you would see in the facility was big pieces of cardboard. You went and bought a TV once a year and it came in a big cardboard box, or it was big cardboard coming from retailers. But with the home delivery of material 1, 2, 3 times a week, we're seeing smaller and smaller cardboard boxes. And MRFs were designed to sort bigger cardboard, not smaller cardboard. And those cardboard boxes are 3-dimensional often. They're not broken down, and so they end up going in with the containers. And so our MRF and other MRFs are continuing to have to make investments to adjust to the changing stream. And that's part of, again, the challenge with recycling, is that we have no control over the material that's coming in, and so we have to adjust in terms of how to deal with that. So after 6, 7, and 8 here, where we've separated the paper from the containers, the paper comes in here on conveyor number 10 and 9, and then, and then you have people that are doing quality control. So again, the system's not perfect, and so they're pulling containers out of the paper. So maybe oftentimes what we'll see is an aluminum can or a plastic bottle has been flattened and kind of acted 2-dimensional and traveled in with the paper, and so that staff there is trying to quality control that to get that material out. The containers that have been separated by all these screens back here come in on line 11. We do have folks on quality control here, again, getting any paper that came over with that. And then it runs up here, up this conveyor here, and then over to number 12. Well, actually right here there's another screen for glass to get more glass out. Anything that's 2-dimensional, 2 inches or less is screened out here. And then we go to number 12, which is a magnet that pulls out the steel cans, so your soup cans and things like that. It's literally a magnet over the conveyor, and you can see the cans pop up. Then we go to number 13 here, which is called an eddy current. And this is what is to pull out the aluminum cans. So aluminum is a non-magnetic metal, and the eddy current is essentially a drum that's circulating that creates a reverse polarity that attracts the aluminum can. So the aluminum cans literally are pulled over by this reverse polarity. They jump over a gate, and everything else falls through. And the next step, okay, so now we've pulled out the glass, we've pulled out as much paper as possible, we've pulled out the steel cans, we've pulled out the aluminum cans. So number 14 is probably the most sophisticated piece of equipment in a material recovery facility. It's what's called an optical sorter. This optical sorter here is what we call a dual eject. So what's happening there is all the material. So this is mostly plastic at this point with some paper that's continued to travel with it. It's thousands of layers lasers that are scanning every piece of plastic and identifying the density of that plastic. And then if it positively identifies a particular type of density, it uses air pressure to blow it in different directions. And this is how we sort particularly number 1 PET bottles. And so it's doing about 1,000 scans per minute, whereas a human that's doing sorting can do 50 to 60 sorts per minute. This is doing, more than 10-fold of, well, almost 20-fold of that. And so this is we're actually right now about to install a second optical sorter to help us continue to sort those plastics. This one, again, is sorting PET and actually paper. It can positively identify the density of paper to sort that using air blowers. Everything else that is not positively identified by the optical scanner here goes back up into our sort house here. And on this conveyor 15 here is where they're sorting out other plastics by hand. They're sorting out any PET bottles that were not sorted by the optical sorter. Again, it doesn't have 100% accuracy. We're also sorting out natural HDP, high-density polyethylene milk jugs. We're sorting out color HDPE, so this is your laundry detergent bottles. Those are the same kind of plastic, but we send them to different markets because the clear has more value than the color. And this is also where we're sorting out polypropylene, so your yogurt tubs, etc. And then we also sort out milk cartons and juice cartons here. That actually goes to a fiber market, but it's plastic coated, which is why you can put milk or juice in it. So it goes to a special type of fiber market where the bottles are pulped for a lot longer than, say, you would pulp cardboard or newspaper. Then the material runs back here to a second eddy current where we pull out more aluminum, and then the remaining material is what we call our end of the line. So that's non-recyclable material that ran through the system or material that we weren't able to capture. And then we analyze that to understand if it was material that we should have been able to capture, why, and what do we need to do to adjust the system. And then once we're finished, so all that material gets sorted into these bunkers over here, and then once we have enough material, we open up the bunker. You can't see it, but it flows out onto a conveyor into a baler, and then we send those bales to market of the different grades. So maybe I'll stop there and kind of see if there are any questions about the process. So I'm going to go into a little bit of detail here about specifically the plastics that we accept and sell and market. So we take number 1 PET bottles and containers. So your soda bottle, we also take what's often referred to as thermoform, or like clamshells that a salad will come in. That's also PET. We take number 2 HDP color and natural bottles, so laundry detergent bottles and milk jugs. Those are 2 separate grades. We can get much higher value for our natural because when it's melted down and pelletized, it's clear and thus has more applications than the color that is essentially a brown. And we take number 5 polypropylene, which is tubs and lids or yogurt containers. We do not take number 3, any containers that are number 3, which is polyvinyl chloride, or number 6, which is polystyrene or styrofoam. There are not markets for those materials, and they're very challenging to sort. So this is what a PET bale looks like. Now, you can see there that most of those PET bottles are clear. You do see your Sprite or Mountain Dew bottle in there, and you see that the cap is still on the bottle and the wrapper is still on the bottle. So a couple of things I want to note here. So when we send this to a PET market, and there's several PET markets across the United States, what they're going to do is they're going to grind down this PET. They're going to wash it to get off the adhesives and to pull off any of those labels. So the labels are not getting recycled. And then they grind it down and they run it through a float sink system. So the caps on PET bottles are polypropylene. The caps and the ringer are polypropylene, and the bottles are PET. Polypropylene floats, PET sinks, and that's how they separate out the polypropylene caps from the PET bottles. That polypropylene cap is recycled back into a polypropylene product. And then they're going to optically sort it. So they're going to take the clear and separate that out from any of the color PET. And the clear PET is going to be extruded and pelletized and can be sold back into PET bottles or other PET applications. The color stuff does not go back into bottles. There's not enough of it to justify that from an economic perspective. So it usually gets what we would call downcycled into bale strapping, some kind of like a plastic strapping that's used for hay bales and things like that. And one of the things that we hear from PET markets for sure is they definitely really don't like the like a blue colored, solid colored PET. We also, the PET markets do not want black PET either in there as well. And so this is where recycling gets challenged, which is that we can accept PET bottles, but the PET markets really only want a specific type of PET, which is that clear PET, and we essentially get penalized for the amount of green or colored PET that we have in a bale. And I think this gets back to a real tension that's been in the industry for a long time and is being talked about a lot right now, which is producer responsibility. So, in order to really make recycling systems work, there needs to be we really believe there needs to be a certain amount of producer responsibility and regulation around packaging, because otherwise our MRF is receiving material that then markets don't actually necessarily want or can't be recycled. And going back to that education question, I mean, we can educate till we're blue in the face, but it's really nearly impossible to get really specific in education to prioritize some packaging over the other when it really all looks the same. You would never be able to educate, well, we want the clear PET bottles, but not the color PET bottles. One of the things that happened in the PET industry about 3 or 4 years ago was there were folks that on the manufacturing and the retail side that were putting a shrink wrap label around PET bottles, and it was called PETG. So it was similar to PET of the bottle, but a little bit different. Again, I'm not a total expert on it. You guys might know more about this than I do. And all of a sudden, we started getting loads of PET rejected by our PET market because that PET shrink wrap sleeve was contaminating the recycling process on their end. Now, we didn't even know what they were talking about because the optical sorter was viewing that PET shrink wrap label as PET. And we had no idea that shrink wrap label was going to screw up the recycling, the process on their end. And all of a sudden, we were getting penalized for that. And that's an example of where there really does need to be producer responsibility. There has to be some accountability upstream in terms of the design of packaging, that it can actually run through the existing recycling infrastructure, and that if there is going to be innovations in packaging, that there needs to be investment in the recycling infrastructure to handle that innovation. As you can imagine, an optical sorter is not cheap, and to have an entire load of PET rejected is a cost to the material recovery facility. So I think that's a really good example of kind of where the industry is really wrestling with where does regulation need to be, and who does need to bear the cost of the investment in recycling infrastructure. Because right now, really, recycling is paid for by the resident on their property taxes. That's how recycling programs are paid for primarily on the residential side. And so there's a lot of discussion in Europe, in British Columbia, in Washington State right now has an extended producer responsibility bill out there because it's viewed as kind of, if you go upstream to the source of the material, that's the best way to kind of get standardization of material within the stream and within the industry. So as I mentioned before, we sort our PET by an optical sorter. PET is about 3.5% of our material by weight. We sell that PET to markets that wash, melt, and pelletize it. Some markets have what's called an FDA non-object, which means they received a letter from the Food and Drug Administration that says they can take those PET bottles and turn it back into food packaging. If they don't have that FDA non-object letter, then if they're recycling PET, it's not going back into food packaging, not going back into a bottle, it's going back into some other kind of application. And I'd say in the last 5 years, we've seen more and more PET markets get that FDA non-object letter. I mentioned already that PET recyclers use a float sink system to separate the PET bottle from the cap. So we actually do ask for people to keep their caps on because that's the best way for the cap to get recycled, and it means the cap isn't contaminating our glass, which is where it would end up if it was on its own. I mentioned colored PET is not desired and downcycled. And as I noted before, an optical sorter cannot sort PET, black PET, and the black plastic that's in the market right now is either PET or polypropylene. So there's really no effective way currently to differentiate black plastic, which is where that challenge comes from. And the price range for PET is anywhere from 10 to 18 cents per pound. and that can vary greatly, and it literally within 1 year can go from 10 cents to 15 cents, back to 12 cents, up to 18 cents. The price of all plastics that we sell is highly related to whatever is happening in terms of the price of oil and natural gas, because the recycled PET is trying to compete with virgin petroleum products. This is a picture of actually, as I think I mentioned, we're installing a second optical sorter. This is the new optical sorter that we will be installing in 2 weeks. I mentioned number 2, high-density polyethylene color. We sort by hand. It's about 1% of our material by weight. We sell that grade of material to markets that wash it, melt it, pelletize it, and mostly turn it back into plastic lumber because of the mixed color. And the price ranges from 15 to 20 cents per pound. That range I'm giving you is kind of over the last 5 years, what have we seen in terms of the range of pricing for it. This is what an HDPE color bale looks like. HDPE natural, high-density polyethylene natural, again, is about 1% of our material by weight. We are able to sell this to markets that wash it, melt it, and pelletize it and turn it back into milk jugs or into other clear HDPE applications. And the price there also ranges from 15 to 20 cents per pound, although actually I will amend this a little bit, but in the last few months it's been even higher than that, up into the 30 cents per pound range. This is what an HDPE natural bale looks like. We also do polypropylene. We commonly refer to it as tubs and lids. It's about 0.8% of our material by weight. Currently, there are no markets that have that FDA approval for recycling it back into food-grade material. So right now, the polypropylene is going into markets that are turning it back into paint cans, railroad ties. But there is a lot of demand for polypropylene, so I imagine in the next couple of years, we'll start to see some markets that have that FDA non-object. There really are actually only 2 markets for polypropylene right now in the United States, whereas there are, probably 40 markets for PET. And the price ranges from 10 to 12 cents per pound for polypropylene. And this is what a polypropylene bale looks like. The plastic contaminants that we get and we don't want, plastic bags, I mentioned that earlier. Bulky plastic like laundry baskets, buckets, toys. Now, a lot of times a laundry basket might be a high-density polyethylene, but it's so bulky that it's challenging to sort that. Or we get buckets with metal handles or toys that might be 2 different kinds of plastic mixed together. And then you have some kind of metal piece that's attached to it. And so sometimes we are actually able to sell our bulky plastics to a high-density polyethylene market, but we get we get 1 cent a pound for it maybe, and sometimes nobody wants to buy it because they have to do additional processing on their side to get out any of the metals or mixed plastics that are in that bulky plastic. Number 3, polyvinyl chloride. There are no markets for this, and you don't see a whole lot of food containers that are in number 3. Number 6, which is polystyrene and styrofoam, there are no reliable markets. It's a brittle plastic, so even if there were a market, it's really challenging to sort that in a MRF situation. It breaks apart very easily into small bits, and so there's really no effective way to sort and bale it. This is a bulky mixed plastic bale. Here's some of the other challenges I think that we're facing in general in the recycling industry and is related to plastic. Recently, we've been seeing beer companies that are coming out with a PET can, or PET looks like an aluminum can, but it's PET with an aluminum top and bottom. Once you combine materials like that, it's very challenging. So either you're going to send that PET to the PET market, and then they're going to ding you for the contamination of the aluminum top or bottom, or it's going to go to the aluminum market and they're going to ding you for the PET. This goes back to that concept of producer responsibility, that there really does need to be standardization and regulation around the materials that are coming into the stream from consumer product companies. Otherwise, it's the MRF and the recycling markets and city recycling programs that are having to deal with the cost of that contamination and the implications of it. I mentioned buckets with metal handles. We see also, for example, there are iced tea containers out there that are in high-density polyethylene, but they have some kind of other plastic coating on it. And so when we have sent that to our high-density polyethylene markets, it's contaminated their recycling process. And so then those particular brands are noted as a contaminant, and we have to quality control those out. I mentioned the PET bottles with shrink wrap PETG. One of the other challenges is lightweighted material. So we've seen a further lightweighting of plastic bottles in the last few years. It's really come from the perspective of using less plastic in the bottle from a climate change and environmental perspective. However, what's happened, particularly in a single stream context, is when that bottle is so light, it compacts really easily and is flattened and then acts like paper through the recycling system. And so it gets into the paper. And so a lot of the quality control that we're doing on our paper lines is trying to get that lightweighted material out. Although that can be a challenge, sometimes you can't even see it because it's gotten embedded into a cardboard box or piece of paper. So I will stop there and see if there are any kind of final questions.